So hello class, this is the Thursday video. I'm very excited because we get to start with calculus today. Yay. Why I'm really excited is because juniors are going to do this next year, so you get this super head start, and then seniors, you're going to have to take this. I know you guys did your PowerPoint presentation at the beginning of the year. Most of you are going to have to take this in college, so you're going to find it very easy because you took it already in high school. So I'm very excited to start calculus with you guys already. Some of you may be intimidated. The word calculus sounds difficult, but I really think you guys can understand it. And actually, I'd rather that I teach it to you before you get super confused in college. Like if you get confused when I do it, you're going to be really confused when you get to the next level. The first topic in any calculus class is something called limits. Okay, a limit is, if I could follow along here on this worksheet again, this is in your packet of notes. Is if f of x becomes arbitrarily close to a unique number L, as x approaches C from other side, the limit of f of x as x approaches C is L. This is written as this. So that's a lot of words. Let me make it even easier for you. What it means is that as a function gets closer and closer to a certain number, this is going to be the y value. Okay? So as x gets closer and closer to some number, okay, as x gets closer and closer to some number, what is the y value? That's the definition of limit. Okay? The reason why we care is because there's some things that we have no idea what the definition is or what the answer is, so we just say, what does it look like it's getting closer and closer and closer to? That's the definition of a limit. Okay? We're only going to learn one method while I'm gone because we might as well just do the easiest ones, and that's called the substitution method. The substitution method means that if I want the limit of any number, as x approaches any number, all I have to do is plug that number into the function. So let's look at letter A, and maybe I could switch to blue. So I want to know this function, what is the limit as it approaches 4? That's how I read this problem. The substitution method says just plug in 4 into the x's. I get 16, this big 8, this is minus 5, 24 minus 5, this is 19. So the limit as x approaches 4 of this function is 19. Okay? Pretty simple, right? All you're doing is plugging in. Same thing, actually even the same number, it says find the limit as x approaches 4 for this function. So let's plug in 4. You may notice that the numerator is the same as the one that we just did, so this is 19. The denominator, I got 4 minus 1, and that becomes 3. That is the limit. 19 and 3. That's a substitution. So just to give you a heads up, before we see some more examples, there are some properties and some operations, and they're actually very simple. If I want the limit as, how can I say this? If I get a number, the answer is just the number. So if I say, what's the limit of 14 as x goes to 5, that answer is just 14. Okay? If it just says, what's the limit of x as x goes to 4, that's just the same thing as plugging in 4 here, that's just 4. So these first two properties, if I'm just saying find the limit of a regular number, it's just that number. If it's just x, then it's just that. This one, as I go to a number, or again, I use the substitution method, or they call it direct substitution. I'll plug in 2 into here, and I get 8. Same exact thing, x goes to 8 of the cube root of x. I plug in 8, I'll get 2. Okay. Operations are very simple. Basically, if I multiply by a number, I could just multiply the number. If I'm adding or subtracting limits, I could just add or subtract the answers. If I'm multiplying or dividing, I could just multiply or divide the answers. And then same thing with the power, I could just raise it to a power. So here's some examples. They say, what if f of x is 10, or the limit of f of x is 10? Let's say what the limit of g of x is 5. So this one says, what's the limit of 6 times f of x? Well, f of x is 10, so this one's just 60. Okay. This one says f of x plus g of x, so 10 plus 5 is 15. This one says f times g, that would be 50. This one says f divided by g, 10 divided by 5 is 2. And this one says f of x squared, 10 squared is 100. So I really think, this topic of calculus, at least for the first section, you guys can understand. So the first two tables, again, these first properties, okay, the only new thing that you learn here is if I just have a number, it's just a number. And operations, very simple. If I'm multiplying, I can multiply. If I'm adding, I just add the two limits, etc. Okay. So let's practice some more direct substitution problems. So these ones say find limits with a table, find limits from a graph. We're not going to do that. All I'm going to do is practice some direct substitution. Okay. And then there's some instances where direct substitution doesn't work, and we'll learn what to do tomorrow. So check this out. If I plug in 1 here, okay, I'm going to get 1 to the third power, which is 1, minus 1, plus 1, minus 1, over 1 minus 1. What do I get? Well, on the top, you see I get 0. And on the bottom, I get 0. I get 0 over 0. Okay? This is not undefined. This does not exist. But for now, I'm just going to leave it like that because I'm going to teach you tomorrow's lesson how do you do 0 over 0. There has to be an answer. It can't be 0, and it can't be undefined. There has to be an answer, and I'll teach you how to do that. Okay, so but for now, box 0 over 0. This one says as x goes to 4, so I'm going to start plugging in 4. 4 squared is 16, and half of 16 is 8. Minus 2 times 4 is 8, plus 3. 8 minus 8 is 0, so I'm left with a 3. In the last one, it says as x goes to 3, so I'll plug in some 3's. You may notice something. 3 minus 3, 9 minus 9, 0 over 0. So do you guys see how direct substitution is not that bad? Okay. In the next section, same thing. It says the limit as x goes to 3. So if I plug in the 3 here, 2 minus 3 is negative 1. If I plug in a 2 here, 3 minus 2 is 1. And if I plug in negative 1 here, I'm just going to get sine of negative pi over 2, right? Sine of negative pi over 2, if I go around the unit circle, or if you need to check your unit circle again, that's negative 1. And this one says negative 2, so I'll plug in a negative 2 here. Negative 2 plus 2 is 0. I'll get 0 on the top. If I plug in a negative 2 down here, negative 2 plus 2 is 0. I have a 0 over 0 case. Okay? We're not going to do these limits that fail to exist. Okay? So as a matter of fact, what I'm going to do is, let me just go on to the next notes, because I think you guys understand direct substitution pretty easily. So turn the page. We're going to go to techniques for evaluating limits. Okay? I'll just do one example today, and I'll do the rest tomorrow. Okay? The problem is that if you have 0 over 0, there has to be an answer. Okay? There just has to be. There's no such thing as 0 over 0 in math. So here's an example of what happens when I plug in a number and I get 0 over 0. So let's plug in this negative 3. Okay? I'll draw in red. Negative 3 squared is 9. Minus 3 minus 6. And on the bottom I get minus 3 plus 3. 9 minus 3 is 6. 6 minus 6 is 0. The bottom I get 0. I get 0 over 0. Okay? What's this divide out technique? Okay? By dividing out, the other thing to do is I need to factor. Okay? And some of you don't like factoring. Factoring is your best friend in the next sections of math. And trust me, because it makes your life a living hell if you don't use factoring. Like, things are very complicated if you don't factor. So what I could do is, you notice that in this top polynomial, I could factor that into x plus 3 and x minus 2. Okay. And you may notice that there's an x plus 3 on the top and x plus 3 on the bottom, so they cancel. So that whole problem that I was trying to solve, that means it's the exact same thing as just x minus 2. Okay? If it means the exact same thing as x minus 2, and I could go back to what I usually do, I'll plug in my negative 3 in here. My answer is actually just negative 5. So this divide out technique is basically factoring or simplifying or crossing out. Okay? Here's another problem. You might need to put in a unit circle, but it says the limit of pi over 2 of sine and tangent. Okay? If I plug in pi over 2, sine of pi over 2 is 1. And tangent of pi over 2, if you remember your graph, it's been a while. If I remember tangent, and then it had it was the period of tangent is this and this. And you remember I had a asymptote, and it went from I don't know if you guys remember tangents, but pi over 2 I have an undefined. So, holy moly, how do I figure out 1 divided by undefined? Okay. Again, I'll use this divide out technique. You'll notice here I can't factor. Okay. But you do remember when we did trig stuff, remember tangent means the same thing as sine over cosine? So let's rewrite this real quick. Okay, so far? So these two mean the exact same thing. Sine over cosine. And then when I have a fraction within a fraction, remember I could flip and multiply. This means the exact same thing as sine times cosine over sine. Right? My sines cancel. So this whole thing just means the exact same thing. Instead of saying sine over tan x, I could have just wrote cosine x. Okay? Now I could do my direct substitution, my substitution method. Cosine of pi over 2, looking at your unit circle, is just 0. And 0 is an acceptable answer. It's 0 over 0 that's confusing. Okay. And then, this last one looks very similar to the one we did. If I plug in 1s, I'll spare you the suspense, but you get 0 over 0. So now I got to figure out how can I factor this? What can I do? This divide out technique, so I can make this nice and easy, and I can plug in the number 1. Okay? Because 0 over 0 means there has to be an answer. Okay? So let's plug in let's try to factor out this denominator. Okay? Because obviously the numerator I can't factor. In the denominator, what I'm going to do is I'm going to do grouping. It might have been a while since you guys have done grouping. Okay? So I'll group like so. This one right here, I'll factor out an x squared. Again, x minus 1. This one I could factor out a 1. So in grouping, you see how these match, these x minus 1. So this whole bottom can be written as, one of them is x squared plus 1 in grouping, these two. And then I'm going to group these two, x minus 1. Now that I've factored the denominator, you may notice that this and this actually cancel. So the whole problem can be just rewritten as 1 over x squared plus 1. Okay. Now that it's all simplified, now I can plug the 1, my direct substitution method, and you'll notice that I could plug in 1 and not get 0 over 0 this time. I'm actually just going to get 1 over 2. So today in class, what I'll do is I'll give you a worksheet. I guess I'll label it Thursday, but I want you to just practice all the factoring problems, okay? In tomorrow's video, what I'm going to do is I'm going to do all these rationalizing problems, and tomorrow we'll just practice rationalizing technique, and we'll do the rationalizing problems in tomorrow's video. So hopefully you understand limits, hopefully you understand calculus, but we're just practicing what they call direct substitution and the factoring, or they call it the, what do they call it again? They called it the divide out technique. So again, your only thing to do is do this practice in class. You might want to staple it, go on to Schoology and put any questions that you have or things that you're confused about, things that you want me to go over. And then I guess I'll see you guys on Monday. All right, thank you. Take care.